Hi students and friends, this is your host and teacher Syed Ayazuddin Haider, and you're watching Learn and Teach by Sayaz. So I will continue my video session for past papers, and I was doing 0620. This time I've selected paper 62 for October November 2023. You know the time is 1 hour. It's paper 6 alternative to practical. You have to answer all the questions. You can use calculator. You have to show all the workings and units, appropriate units in this paper. The total mark for this paper is 40. The notes for use in qualitative analysis are provided in the question paper. It will be like this. It's a test for anions, test for aqueous cations, test for gases, and flame test for metal ions. So let's start the paper. Here's question number 1. Some seashells contain a mixture of the insoluble compounds calcium carbonate and silicon 4 oxide only. Calcium carbonate reacts with dilute hydrochloric acid to form the soluble salt, calcium chloride. Silicon 4 oxide does not react with or dissolve in dilute hydrochloric acid. A student wants to find the percentage of silicon 4 oxide in a seashell. The first 4 steps of the method the student uses are shown. Step number 1, the student grinds the seashell to form a powder. Step 2, the student finds the mass of the powdered seashell. Step number 3, the student adds the powdered seashell to an excess of dilute hydrochloric acid and heats while stirring with a glass rod as shown in figure 1.1. Step 4, the student filters the mixture as shown in figure 1.2. So here's a setup or apparatus used for this purpose. Part A, name the apparatus used to grind the seashell to form a powder in step 1. We use mortar and pestle, or you can write pestle and mortar. Mortar and pestle. B, why it's important that the dilute hydrochloric acid is in excess in step 3. Definitely, so that all the CaCO3 reacts or dissolves. C, name the items of apparatus labeled A and B in figure 1.2. Here's figure 1.2. A, it's a filter funnel, and B is conical flask. Moving to next part. Part D, the residue obtained in step 4 is not pure. 1. Identify one substance other than water that is in the residue and prevents it from being pure. Definitely it must be the salt or the acid. Here the acid is hydrochloric acid. Or salt, which is calcium chloride in this case. Coming back to the question, you see they are saying this acid, hydrochloric acid, the soluble salt, calcium chloride. So you can write any one of these. Part 2. The student washes the residue. Describe 2 additional steps the student must now take to find the percentage of silicon 4 oxide in the seashell. The student has to dry and then determine the mass. Dry the residue, then determine the mass. of residue. Okay, moving to next question. Question number 2. A student investigates the temperature change when aqueous sodium hydroxide neutralizes dilute hydrochloric acid. The equation for the reaction is shown. Here's the reaction. NaOH plus HCl gives NaCl plus H2O. The student does 6 experiments. So here the experiment. Experiment 1. Fill a burette with dilute hydrochloric acid. Run some of the dilute hydrochloric acid out of the burette so that the level of the dilute hydrochloric acid is on the burette scale. Fill a second burette with aqueous sodium hydroxide. Run some of the aqueous sodium hydroxide out of the burette so that the level of the aqueous sodium hydroxide is on the burette scale. Run 1 centimeter cube of dilute hydrochloric acid from the burette into a boiling tube. Run 9 centimeter cube of aqueous sodium hydroxide from the second burette into the same boiling tube. Stir the mixture with the thermometer and measure the highest temperature reached. Measure the pH of the mixture in the boiling tube. Rinse out the boiling tube with distilled water. Experiment 2. Run 2 centimeter cube of dilute hydrochloric acid from the burette into the boiling tube. Run 8 centimeter cube of aqueous sodium hydroxide from the second burette into the same boiling tube. Stir the mixture with the thermometer and measure the highest temperature reached. Measure the pH of the mixture in the boiling tube. Rinse out of the boiling tube with distilled water. Experiment 3. Repeat experiment 2 using 3 centimeter cube of dilute hydrochloric acid and 7 centimeter cube of aqueous sodium hydroxide. Experiment 4. Repeat experiment 2 using 6 centimeter cube of dilute hydrochloric acid and 4 centimeter cube of aqueous sodium hydroxide. Experiment 5. Repeat experiment 2 using 7 centimeter cube of dilute hydrochloric acid and 3 centimeter cube of aqueous sodium hydroxide. Experiment 6. Repeat experiment 2 using 8 centimeter cube of dilute hydrochloric acid and 2 centimeter cube of aqueous sodium hydroxide. Part A. Use the description of the experiments and the thermometer diagrams to complete table 2.1. So in experiment 1, volume of dilute hydrochloric acid is 1, volume of aqueous sodium hydroxide. So what will be the volume of sodium hydroxide? Experiment 1, 2, 3, 4, 5, 6. So if you see in one, they've used 9 centimeter cube. 9 in one experiment 1, 8 in experiment 2, 7 in experiment 3, 4 in experiment 4, 3 in experiment 5, 2 in experiment 6. So these are the reading 9, 8, 7, 4, 3, 2. 9, 8, 7, 4, 3, 2. Highest temperature reached in centigrade. If you look at the reading, it must be 26 degrees centigrade. 26. What about this one? 26, 27, 28 degrees centigrade. For experiment number 3, it's 30. For experiment number 4, it's 30.5. For experiment number 5, now it's decreasing. It's 29 degrees centigrade. What about experiment number 6? 26, 27, 27.5. B. Add a suitable scale to the y-axis in figure 2.1. Your scale should extend by 2 centimeter cube above your highest temperature in table 2.1. Plot your results from experiments 1 to 6 on the grid. Draw 2 straight lines through your points, one through the first 3 points and one through the last 3 points. Extend your straight lines so that they cross. We have highest temperature for the volume of dilute hydrochloric acid. We have 1, 2, 3, 6, 7, 8. 1, 2, 3, 6, 7, 8. I'm showing you again the volume of hydrochloric acid used here. This one is volume of hydrochloric acid. 1, 2, 3, 6, 7, 8. What about highest temperature reached? 26, 28, 30, 30.5, 29 and 27.5. For your convenience, I am writing these readings on the left hand side. We got 26, 28, 30, 30.5, 29 and 27.5. So I'll take this one as 10, 20, 30, 40. This must be 50. So experiment 1. For experiment number 1, reading is 20. The volume of hydrochloric acid is 1 and the highest temperature attained is 26 degrees centigrade. So it must be here. 2, 3, 4, 5, 6. It must be here, 26. For what volume? 2, 28 degrees centigrade. It must be here. For 3, we have 30. Write it here, 30. For 6, volume 6, we have 30.5. 30.5, it must be here. For 7, we have 29. 29 must be here. For 8, we got 27.5. So it must be here. Now we have two straight lines for the first 3 points and as well as last 3 points. So these are the first 3 points. These are the first 3 points. The last 3 points, it must be from this side. See the intersecting point? See the point on the graph where the two straight lines cross is where all of the aqueous sodium hydroxide reacts with all of the dilute hydrochloric acid to form neutral solution. 1. Use your graph in figure 2.1 to reduce the volume of dilute hydrochloric acid and the volume of aqueous sodium hydroxide that react together to produce a neutral solution. Show your working on figure 2.1. So if you look at this, the volume of hydrochloric acid, it's 4.567. It must be 4.7. 4.7 for dilute hydrochloric acid. What about sodium hydroxide? These are the readings for aqueous sodium hydroxide. If you look at the highest temperature attained in this, that's 33. It's like 33, around 30.5 and 33. So that will be the highest temperature attained. So volume must be between 4 and 7. It must be between 4 and 7. You can write 5 and 7. Predict the pH of the solution in the boiling tube when the volume in C1 are mixed together. Definitely they are producing neutral salt, so you have pH of 7. Number 3, deduce which solution, dilute hydrochloric acid or aqueous sodium hydroxide, is the most concentrated. Now if you compare the volume of hydrochloric acid with sodium hydroxide, you see less volume of hydrochloric acid used as compared to sodium hydroxide. So sodium hydroxide must be the dilute solution here, and dilute hydrochloric acid is a concentrated solution because of less volume of hydrochloric acid used here. So you write most concentrated solution, dilute hydrochloric acid. And for the reason, what you write as volume is smaller as compared to sodium hydroxide. Volume of acid is smaller than sodium hydroxide, NaOH, to become neutral. D. State how the pH and temperature recorded in each experiment would differ, if at all, if a polystyrene cup is used in place of the boiling tube. Now explain, you have to explain the difference. In case of pH, there will be no change, because the pH changes when the H positive ion from the acid and OH negative ion of the alkali reacts together. And if the concentration of H positive ion is higher, the pH will be lower. On the other hand, the concentration of the OH negative ion is higher, the pH will be higher. So there will be no change in this case. Now, if you have polystyrene cup, because polystyrene cup is a better insulator than glass, then there will be higher or bigger difference. We'll write higher or greater difference. Explanation: polystyrene is a better insulator. E. The volumes of solutions used in these experiments were measured using a burette. Explain why a volumetric pipette could not be used instead of a burette in this experiment. Now, the volumetric pipette, they do not measure variable volumes. Moving to next question. Here's question number 3. A student tests two substances, solid K and solid L. Test on solid K. The student dissolves solid K in water to form a solution K. The solution divides solution K into 4 portions. Table 3.1 shows the test and the student's observations for solution K. Here's table 3.1. To the first portion of K, add a few drops of aqueous ammonia, white precipitate formed. To the second portion of solution K, add a few drops of acidified aqueous potassium manganate 7, pale purple solution. Test 3. To the third portion of solution K, add 1 centimeter cube of dilute nitric acid followed by few drops of aqueous silver nitrate, cream precipitate. Test 4. To the fourth portion of solution K, add aqueous chlorine. The solution becomes orange. A1. Identify two cations that test 1 shows could be in solid K. So here's the test for ions with aqueous ammonia. It must be cations. Test for cations with aqueous ammonia. These are the cations. If you see, we have aluminium. Yes, aluminium and zinc. We have aluminium and zinc ions, that is Al3 plus and Zn2 plus, which gives the same result. They both form white precipitate. So you write straight away Zn2 plus and Al3 plus. Number 2, describe an additional test that could be carried out on solution K to confirm which of the two cations you have identified in A1 is in solid K. Explain how the test will show which of these two cations are in solid K. So if you look at this, thing missing is add excess of aqueous ammonia. One is soluble, Zn2 plus soluble in aqueous ammonia, while Al3 plus insoluble. So you write add aqueous ammonia. In this case, now you have to mention for Zn2 plus ion or zinc ions, color in the solution. For aluminium ions, PPT remains because it's insoluble. You can even write unchanged. B, identify the anion solid K. Now, if you look at the results, the anion, they have tested with nitric acid followed by few drops of aqueous silver nitrate, creamy precipitate. Test for the anions. Here is the test for the anions. We have 3 anions here, which will undergo the same test: dilute nitric acid and aqueous silver nitrate, all these 3. And if you look at this clearly, creamy precipitate is obtained with Br negative ion. So you will straight away write Br negative. You look at one more test, they have added aqueous chlorine and the solution is turning orange due to due to formation of Br2, because Br negative displaced by Cl negative, which is coming from aqueous chlorine. Chlorine is above bromine in the periodic table and it's group 7. So it will definitely replace the bromide ion. And this orange color is due to the formation of Br2 in the solution. So this will confirm the presence of Br minus ion. Test on solid L. Solid L is barium nitrate. Complete the respected observations. See, the student carries out a flame test on solid L observations. So we have, what do we have? We have barium nitrate. So flame test for the cations. If you look at this list, so we have light green for Ba2 plus. So you write here light green, or even you can write apple green, light or apple green. Name the test, flame test. They have already mentioned. The student dissolves the remaining solid L in water to form solution L. The student divides solution L into 3 portions. D. To the first portion of solution L, the student adds a piece of aluminum foil and 5 centimeter cube aqueous sodium hydroxide and warms a mixture. The student test for any gas produced. Now it's a nitrate, so it must be the test for the nitrate ion. NO3 minus. So if you look at the anion nitrate ion test, so here's the nitrate ion. So they are adding aqueous sodium hydroxide and aluminum foil, warms carefully, ammonia produced. So ammonia produced, in this case, the student tests for any gas produced. So test for the ammonia gas. What is the test for ammonia gas? So here's a test for ammonia gas. Turns damp red litmus paper blue. So you write red litmus paper turns blue. Red litmus paper turns blue. E. To the second portion of solution L, the student adds 1 centimeter cube of dilute nitric acid and a few drops of aqueous silver nitrate. Observations. We have barium nitrate. So if you look at this, so if you look at the test for the sulfate ion gives the test with barium nitrate. So sulfate ion will give the test for with barium nitrate. It's a test for barium. It gives white precipitate with this. So you'll definitely see no change here, part E, because we don't have any sulfate ion here. So in E, you'll write no reaction or no change. So part E. To the third portion of solution L, the student adds 1 centimeter of dilute sulfuric acid. Observations. Now they are adding sulfuric acid. Now this sulfuric acid contains sulfate ion. So we have Ba plus 2 and SO4 minus 2. So they will form BaSO4. They will react together, forming this BaSO4, which is white precipitate. The observation will be white precipitate, PPT. Moving to next question, this will be the last question. The solubility of solid sodium sulfate in water changes as the temperature of the water changes. Plan an experiment to find out how the solubility of sodium sulfate in water changes with temperature. You are provided with sodium sulfate, distilled water, and common laboratory apparatus. So in this experiment, it's a very simple one. The steps are simple, and the marks, the total mark for this question is 6. So you have to write any 6 points from these. You have to start with the stated or known volume of water. Known volume of H2O. Then you have excess stated or excess mass of Na2SO4. Add it. Add stated or excess mass of Na2SO4. Na2SO4 is sodium sulfate. The next part, add the water and solute in a suitable container. You can write take solute and water in a suitable container. Now you have to write the name of the container here. This will award you 1 mark. You can take like test tube. You can even take boiling tube or beaker, flask. You can even use polystyrene cup for this purpose. Next step, these are the steps. You have to mix. For mixing, you can use the terms like stirring, mixing, or even shaking. Then you have to filter. You have to filter this. Because you are checking the solubility of sodium sulfate. That's why you have to filter it. Now dry and weigh the residue. And weigh the residue. If you are finding mass, if you are finding the mass not dissolved, or the next option for this one, heat the solution to evaporate. Heat solution to evaporate. Heat solution to evaporate all water and weigh residue. If you are finding mass that dissolves, we repeat the experiment. Repeat the experiment at another temperature. You can repeat the experiment at another temperature. Because if you read the question, they are saying find out solubility of sodium sulfate in water, change with temperature. So you have to repeat at another temperature. So in any 6 point from this, so I think, so for you, the important points that you have to choose from these is like volume of water, stated volume of excess sodium sulfate, then the naming of apparatus, then you have filter, drying, Any one of these, you have 1, 2, 3, 4, 5, and the last one repeat at another temperature. Even if you skip this one, will award you all 6 marks, because if you're adding this will definitely mix a step. So thanks for watching. Press like and share my videos for more videos. Subscribe to my channel, press the bell icon.